Welcome to today's mathematics class. In today's class, we are going to provide solution to this beautiful exponential equation. It says solve for x. 3 exponent 2 roots x plus 3 exponent 2 root x plus 3 exponent 2 root x equal to 9 exponent square root of x plus 1. So this exponential equation involves radical equation. Now, since we are having the same base 3 base 3 here, so and the exponent is the same, so it makes the job very easy for us. You can either use a substitution or you simply just solve straight ahead. Now let's solve straight ahead, okay? How many times does this term appear? It appears 3 times. So which means 3 multiplying 3 exponent 2 root x. Then here we can break this right hand side since the left hand side is already in base 3. Inside 9 is same thing as square root of 3 squared. So it becomes 3 raised to power 2. And this is already an exponent. Then we got to put it there. Becomes x plus 1. So remember, 3 here is also a base now. It can also be written as raised to power 1. Now do not forget this law of indices. So I have a raised to power n multiplying a raised to power n. I'm going to have a raised to power n plus n. So remember this law. We're going to apply it to the left hand side. 3 raised to power 2 root x. Now we add the power, which is 1, then equal to 3 2 root what? X plus 1. Now let us equate the exponents since the base are the same, okay? We cannot say 2 root x plus 1 equal to 2 exponents 2 root what? X plus 1 inside. Now we need to get rid of the radical. The only way to do this is to square both sides, so that when you square radical, so that the square root of a all squared, this will cancel out this to give us a. So we are going to apply that now to the both sides. So which means we are going to have 2 root x plus 1, then all squared, then equal to the right hand side 2 roots x plus 1, everything all squared. Now the left hand side here, we're having a binomial in the brackets, okay? So while this right hand side here is just a monomial, so these 2 here, we affect this one, okay? Then to take care of this, so it will affect these 2 here, become 2 squared, that's 4. While this left hand side here, we are going to open the brackets. Going to be 2 root x plus 1. We multiply again 2 root x plus 1. Then equal to here, we're having 4 now, because 2 squares 4. Then opening here, x plus 1. Because the root here is gone. Now let us multiply. 2 times 2 is 4, okay? Then root x times root x. In surd, when a radical multiplies a radical, for example, root a times square root of a is equal to a. So we'll make use of this property in surd, okay? Now, we are going to apply that here. 2 times 2 is 4. Then root x times root x is x. So this gives us 4x. Then 2 root x now times 1 gives us 2 root x. Then 1 times 2 root x gives us 2 root x again. 1 times 1 is 1. Now let's open the bracket on the right hand side. We have 4x plus 4. Okay, that is for the right hand side. Now let us go further. Let's proceed. Here, the next line gives us 4x. we're having 2 root x, another 2 root x. So it will now give us plus 4 root x. Then this one, we have plus 1 equal to 4x plus 4. Now let us collect the like terms. We're having 4x here. 4x and this 4x here can just cancel out. We can say 4x, then take this one to this side, minus 4x, then plus this of 4 root x equal to, then this one, take it to the other side, becomes 4 that is here minus 1. Then this one and this one is gone. So we can now have 4 root x equal to 3. Now, let us square both sides again to get rid of the radical sign. So squaring both sides, we have 4 root x all squared equal to 3 squared. So this one will affect the 4, so it gives us 16. Then this one will cancel out the root. It will now remain x. We have 16x equal to 9. Now, of course, we can get x by dividing both sides by 16. Divide both sides by 16. So your final answer, x equal to 9 over 16. So this is our answer. If you want to use the substitution method, it will still arrive at the same answer. I hope you understood this solution. If that is true, please help us to share this post so we can get to a greater number of students on this platform. Bye.